السلام ورحمة الله وبركاته. الأخوة الأفاضل، الحضور الكريم، الرجاء البقاء في مقاعدكم، تكرما منكم الرجاء البقاء في مقاعدكم.
أعوذ بالله من الشيطان الرجيم. إن الله فالق الحب والنوى يخرج الحي من الميت ومخرج الميت من الحي ذلكم الله فأنى تؤفكون. فالق الإصباح وجعل الليل سكنا والشمس والقمر حسبانا ذلك تقدير العزيز العليم. وهو الذي جعل لكم النجوم لتهتدوا بها في ظلمات البر والبحر قد فصلنا الآيات لقوم يعلمون. وهو الذي أنشأكم من نفس واحدة فمستقر ومستودع قد فصلنا الآيات لقوم يفقهون. وهو الذي أنزل من السماء ماء فأخرجنا به نبات كل شيء فأخرجنا منه خضرا نخرج منه حبا متراكبا ومن النخل من طلعها قنوان دانية وجنات من أعناب والزيتون والرمان مشتبها وغير متشابه انظروا إلى ثمره إذا أثمر وينعه إن في ذلكم لآيات لقوم يؤمنون. صدق الله العظيم.
بسم الله الرحمن الرحيم. الحمد لله الذي هندس الكون بإتقانه وبديع حكمته وجعل العقل معماراً للأرض ومصباحاً لهدايته. نحمده على ما علمنا من علم يشيد البناء ويخدم الإنسانية، والصلاة والسلام على سيدنا محمد الذي أرسى قواعد الحق ورفع بنيان الأخلاق وهدى الأمة إلى صراط الرشاد ونور اليقين. صاحب السمو السيد فهر بن فاتك بن فهر آل سعيد الموقر راعي المؤتمر، سعادة الدكتور سعيد بن حمد الربيعي المحترم رئيس جامعة التقنية والعلوم التطبيقية، المكرمون وأصحاب السعادة وممثلو الجهات العسكرية والأمنية والمدنية، الأفاضل رؤساء التنفيذيون ومديرو العموم، الأفاضل رؤساء الجامعات وعمداء الكليات، الأفاضل نواب ومساعدو رئيس جامعة التقنية والعلوم التطبيقية وعمداء كلياتها، الضيوف الكرام، السلام عليكم ورحمة الله وبركاته. أهلا وسهلا بكم في هذا المحفل العلمي، حيث تلتقي العقول لترسم بالهندسة ملامح غد أكثر نماء واستدامة، متمسكين برؤية تبني الوطن وتعلي شأن المعرفة، مع انطلاق فعاليات المؤتمر الدولي الثالث لجامعة التقنية والعلوم التطبيقية تحت شعار الذكاء الاصطناعي والتقنيات الناشئة لمستقبل صفري الكربون، والذي يتزامن مع انطلاق خطة التنمية الخمسية 11 2026-2030 التي تمثل منتصف الطريق نحو تحقيق رؤية عمان 2040، وقد جعلت من التحول التدريجي إلى اقتصاد مخفض الكربون وتعزيز الاستدامة البيئية هدفاً استراتيجياً محورياً تتكامل فيه السياسات والبرامج القطاعية. إن اجتماعنا اليوم ليس مجرد مؤتمر للعلماء والباحثين، بل هو ميثاق بين الفكر والعمل وعهد بين الإنسان والطبيعة نسعى فيه إلى وصول العقل بالبيئة وربط التنمية بالحكمة وجمع التقنية بالرؤية كي يبقى هذا الكوكب مسكناً صالحاً وتظل موارده مستدامة للأجيال. إن هذا الجمع العلمي المبارك شاهد على أن الوعي إذا اقترن بالعلم أثمر، والعلم إذا اقترن بالمسؤولية أزهر. فنحن هنا لنصغي إلى الأرض ونحتضن المستقبل ونرسم بخطانا طريق الاستدامة نحو حياد كربوني صفري يحقق مسار التنمية المتوازنة التي تليق بسلطنة عمان تاريخاً وحاضراً ومستقبلاً. Praise be to Allah who has blessed us with the resources. Peace and blessings be upon Prophet Muhammad, whose teachings enforce us to maintain sustainability and preserve the resources. We extend our warm greetings to the patron of this conference, His Highness Sayyid Fahar bin Fatih Al Saeed, His Excellency Dr. Saeed Al-Rubai, the Vice Chancellor of the University of Technology and Applied Sciences. Respective officials, academic leaders, and partners, also our honored guest. Today, we announce the launch of the third international conference of the University of Technology and Applied Sciences leads under the theme AI and Emerging Technologies for a Net Zero Future. This conference coincides with the start of the 11th Five-Year Development Plan, 2026-2030, the midpoint toward realizing Oman Vision 2040, which has the priority toward transition to low-carbon economy and strengthened environmental sustainability. Our gathering today is more than a scientific forum. It's a pledge that connects knowledge with action, blend humanity to its natural world. We strive to harmonize intellect with the environment, advance technology with purpose, and steer development with wisdom to secure a sustainable future for generations to come. Together, we shape the path towards sustainability, carbon neutrality, and balanced development worthy of Oman, its heritage, its present, and its future.
وفي ضوء أهمية التطورات العالمية المتسارعة للتقنيات المتقدمة وتطبيقاتها، ومنها تطبيقات الذكاء الاصطناعي لما توفره من فرص لتحسين الإنتاجية والكفاءة لمجموعة واسعة من القطاعات، ومن منطلق إدراكنا بأهمية تنويع مصادر الدخل القائم على أساس التقنية والمعرفة والابتكار، فإننا عازمون على جعل الاقتصاد الرقمي أولوية ورافداً للاقتصاد، هنا بضرورة إعداد برنامج وطني لتنفيذ تقنيات الذكاء الاصطناعي وتوطينها، مع الإسراع في إعداد التشريعات التي ستسهم في جعل هذه التقنيات كأحد الممكنات والمحفزات الأساسية لهذا القطاع. وإيماناً منا بأهمية معالجة التأثيرات المتعلقة بتغيير المناخ والبحث عن مصادر للطاقة المتجددة النظيفة، وفي إطار سعي الحكومة المتواصل لتحقيق الحياد الصفري الكربوني الذي سبق أن اعتمدنا عام 2050 موعداً للوصول إليه، فقد وجهنا بالعمل على تسريع إجراءات قطاع الطاقة المتجددة ووضع الأطر القانونية والسياسات اللازمة لنموه، وتقديم الحوافز والتسهيلات لتشجيع الاستثمارات الأجنبية والصناعات المحلية، والعمل على توطين هذه التقنية.
في لحظة وطنية مفصلية تتلاقى الرؤية بالتخطيط والعلم بالتنمية لتقود عمان مرحلة جديدة من التحول نحو اقتصاد متنوع ومستدام، وانسجاماً مع أهداف الخطة التنموية الخمسية 11 التي جعلت من الاقتصاد منخفض الكربون والذكاء الاصطناعي والابتكار التقني ممكنات رئيسية للنمو. يأتي هذا المؤتمر منصة علمية لتحويل المعرفة إلى أثر، ومن خلال استراتيجياتها المؤسسية تؤكد جامعة التقنية والعلوم التطبيقية التزامها بتعزيز البحث والابتكار وتمكين التحول الرقمي وبناء شراكات فاعلة تسهم في الاستدامة البيئية وصناعة القرار القائم على العلم. هنا تلتقي التقنيات الناشئة بالمسؤولية ويجتمع الذكاء الاصطناعي بالاستدامة لنرسم معاً مستقبلاً حيادي الانبعاثات الكربونية.
ينعقد مؤتمرنا هذا في نسخته الثالثة تماشياً مع الجهود الوطنية لتنفيذ التوجيهات السامية للوصول إلى الحياد الصفري الكربوني بحلول العام 2050، وخدمة لتحقيق أولويات رؤية عمان 2040 الرامية إلى توفير بيئة عناصرها مستدامة وآمنة، نظمها فعالة ومتزنة، ومواردها متجددة، وذلك عبر ربط محاور المؤتمر وأهدافه بمستهدفات خطة التنمية الخمسية 11، وذلك على النحو الآتي: الحياد الكربوني وإدارة التلوث والانبعاثات يدعم الهدف الاستراتيجي الثاني في الخطة، الطاقة المتجددة والهيدروجين الأخضر لتوسيع مزيج الطاقة المستدام، الاقتصاد الدائري لتقليل الفاقد وتعظيم القيمة المضافة، الذكاء الاصطناعي وإنترنت الأشياء للبيئة والتنمية لتحويل البيانات إلى أدوات قياس ورصد وتحقق تدعم صنع القرار، تطبيقات النانو وعلوم المواد والتصميم الهندسي المستدام للخروج بحلول تقنية تخفض الكلفة البيئية وترفع الكفاءة الاقتصادية، العلوم البيولوجية والبيئية والسلوك المجتمعي لتعزيز ثقافة الاستدامة وتأطيرها وحوكمتها. صاحب السمو السيد راعي المؤتمر، المكرمون وأصحاب السعادة، الحضور الكريم، نجتمع اليوم لنحول المعرفة إلى سياسات وبرامج، والبحث إلى أداة ووسيلة، والرؤية إلى نتيجة وواقع، فنقيم جسراً بين المختبر والقرار وبين الفكرة والآثار، لنفتح للغد أبوابه بالعقل الذي يبتكر وبالقيمة التي تؤثر. وعليه وباسمكم جميعاً نعلن عن انطلاق أعمال المؤتمر الدولي الثالث للعلوم والهندسة البيئية والتنمية المستدامة، الذي يجمع الباحثين والمنشغلين بقضايا البيئة والاستدامة تحت سقف واحد، استمراراً لتلك الجهود الحثيثة التي تبذلها جامعة التقنية والعلوم التطبيقية لحل مشكلات البيئة والاستدامة. أما الآن فندعو سعادة الدكتور سعيد بن حمد الربيعي رئيس جامعة التقنية والعلوم التطبيقية ليلقي كلمة الجامعة، فليتفضل مشكورا. And now I am honored to invite His Excellency Dr. Saeed bin Hamad al-Rabi'i, the Vice Chancellor of the University of Technology and Applied Science, to deliver the university address and officially inaugurate the conference. Your Excellency, the floor is yours.
بسم الله الرحمن الرحيم. الحمد لله الجليل العظيم العليم القدير، والصلاة والسلام على سيدنا محمد البشير النذير، معلمنا الاقتصاد وحسن التدبير، والناهي عن الإسراف والتبذير، وعلى آله وصحبه الطاهرين. صاحب السمو السيد فهر بن فاتك بن فهر آل سعيد الموقر، راعي المؤتمر، المكرمون، أصحاب السعادة، الضيوف الكرام، زملائي الباحثين والأكاديميين، السلام عليكم ورحمة الله وبركاته. إنه ليشرفني أن أرحب بكم في جامعة التقنية والعلوم التطبيقية لنفتتح أعمال المؤتمر الدولي الثالث للعلوم والهندسة البيئية والتنمية المستدامة. هذا المؤتمر الذي غدا بفضل تراكم خبراته وتطوير مساراته وتطوير ممارساته منارة علمية تسهم في صياغة الوعي وصناعة الحلول ودعم القرار الوطني في قضايا البيئة والتنمية. أيها الحضور الكريم، عندما أطلقت الجامعة النسخة الأولى من هذا المؤتمر في عام 2022 كنا ندرك أن الاستدامة البيئية ليست مساراً بحثياً فحسب، بل هي خيار وطني استراتيجي، وأن العلوم البيئية والهندسية ليستا بمجالات تخصصية منعزلة، بل محركات فاعلة لتحقيق مستهدفات رؤية عمان 2040. ثم جاءت النسخة الثانية في عام 2024 لتثبت أن الاستثمار في المعرفة البيئية ينتج أثراً عملياً، حيث خرجت تلك النسخة بتوصيات تحولت إلى مشروعات بحثية ممولة وممارسات تطبيقية ونشاط بحثي مكثف أثمر خلال عامين عن نشر عشرات الأوراق العلمية في دوريات علمية مرموقة، وهو إنجاز نعده إحدى ثمار هذا المؤتمر ومسارا نواصل البناء عليه. ولأن العمل المؤسسي لا يكتمل إلا بتكامله مع التوجهات الوطنية، فقد جعلت الجامعة من هذا المؤتمر أداة لدعم مؤشرات رؤية عمان 2040، وخاصة المتعلقة باستدامة البيئة والموارد الطبيعية، الاقتصاد القائم على المعرفة والبحث العلمي والابتكار. كما يأتي تنظيم هذا المؤتمر اليوم في لحظة وطنية مفصلية بالتزامن مع انطلاق خطة التنمية الخمسية 11 2026-2030، والتي تضع في صلب أهدافها التحول التدريجي إلى اقتصاد منخفض الكربون، وتعزيز الشراكات البحثية، وتمكين التكنولوجيا المتقدمة، وفي مقدمتها التقنيات الناشئة والذكاء الاصطناعي والهيدروجين الأخضر والاقتصاد الدائري. إن انعقاد هذا المؤتمر تحت شعار الذكاء الاصطناعي والتقنيات الناشئة لمستقبل صفري الكربون ليس اختياراً لغوياً فحسب، بل هو رسالة واضحة بأن الجامعة عازمة على جعل المعرفة العلمية سنداً للسياسات العامة، وأن البحث العلمي ليس نشاطاً أكاديمياً منعزلاً، بل ذراعاً تنموياً يخدم الدولة ومؤشراتها وأولوياتها. صاحب السمو المكرمون، أصحاب السعادة، الضيوف الكريم، الحضور الكريم، لقد شاركت في النسختين السابقتين كوكبة من الباحثين من مختلف دول العالم، وأسهم تفاعلهم العلمي في رفع مستوى الأبحاث المحلية ودفع مسار التعاون الدولي. وها نحن اليوم نرحب بمشاركات أرحب وبخبرات أعمق وبحضور متميز من مؤسسات أكاديمية عالمية مرموقة، لنؤكد أن الجامعة ماضية في الانفتاح المعرفي والارتباط البحثي والتواصل الدولي الذي يعزز مكانة عمان العلمية. إننا في جامعة التقنية والعلوم التطبيقية نعمل على جعل البيئة والاستدامة محوراً رئيساً في برامج التمويل البحثي وفي الأولويات العلمية وفي الشراكات مع المؤسسات الصناعية والحكومية. وليس هذا ترفاً بحثياً، بل هو ضرورة وطنية تتسق مع التوجيهات الكريمة لصاحب الجلالة السلطان هيثم بن طارق حفظه الله ورعاه بالعفاءة الطاقة ودعم الاقتصاد الأخضر. وفي هذه النسخة من المؤتمر نتطلع إلى أن تكون المداولات العلمية منطلقاً لتوصيات عملية تسهم في تعزيز جاهزية سلطنة عمان للتحولات البيئية العالمية، وتدعم جهود الدولة في إدارة الموارد وتقليل الانبعاثات وتوظيف التقنيات الناشئة لخدمة التنمية المستدامة. أيها الحضور الكريم، إن ما ننجزه اليوم سيبقى أثره غداً، وما نزرعه اليوم سيثمر في مستقبل أجيالنا. لذلك ستواصل الجامعة وعبر كل منتسبيها قيادة وأكاديميين وطلبة وباحثين تبني مخرجات هذا المؤتمر ودعم تحويلها إلى مشروعات بحثية وسياسات تطبيقية وشراكات وطنية ودولية، وتسهم في صناعة مستقبل بيئي آمن ومستدام لعمان. وفي الختام أتقدم بجزيل الشكر لراعي الحفل صاحب السمو الموقر، وللباحثين والمشاركين، ولجميع اللجان العاملة، ولشركائنا من المؤسسات الوطنية والدولية على إسهامهم في إنجاح هذا الحدث العلمي. وأتمنى لجلسات المؤتمر أن تفتح آفاقاً واسعة لتقديم حلولاً مبتكرة وتعمق من أثر العلم في خدمة الوطن، وتجدد نهضته تحت القيادة الحكيمة لحضرة صاحب الجلالة السلطان هيثم بن طارق حفظه الله ورعاه. والسلام عليكم ورحمة الله وبركاته.
في قلب عمان ترتفع جامعة التقنية والعلوم التطبيقية كمنارة للمعرفة، حيث يمتزج العلم بالإبداع والماضي بالحاضر لتكون أكثر من مجرد صرح علمي. إنها مجتمع ينبض بالحياة، مجتمع يحتضن التنوع ويجمع بين الأجيال لبناء مستقبل أفضل. ب11 فرعاً موزعة في أرجاء سلطنة عمان و6 كليات. تحتضن الجامعة مجتمعاً طلابياً واسعاً يرفدها بالحيوية والتجدد. تفتح الجامعة أبوابها أمام آلاف الطلبة، تقدم لهم بيئة تعليمية محفزة متجددة ومتنوعة. في أروقة هذه الجامعة تكتب فصول جديدة من قصص النجاح وتنسج خيوط الإنجاز. هنا في كلية الهندسة والتكنولوجيا يولد الإبداع من رحم التحديات، ليبتكر المهندسون حلولاً لمشاكل الغد، وتحرر الطاقات الفنية والإبداعية لتبدع ما لم يرى. في كلية الصناعات الإبداعية وتبنى جسور المستقبل الرقمي بأيد خبيرة ومهارات متقدمة. في كلية علوم الحاسوب والمعلومات، كلية العلوم التطبيقية والصيدلة تتشكل فيها قدرات تعمل على إنتاج ما يسهم في خدمة البشرية وصناعة مستقبل أفضل. في كلية الاقتصاد وإدارة الأعمال تصقل عقول قادة المستقبل ليخوضوا معترك الأسواق والأعمال. وفي كلية التربية تزرع بذور المعرفة في نفوس المعلمين ليكونوا شعلة تضيء دروب الأجيال القادمة. كل كلية في هذا الحرم العريق تعكس رؤية الجامعة في الريادة في مجال التعليم التقني والتطبيقي، لتسهم في بناء مجتمع معرفي مستدام يدفع بعجلة التقدم نحو الأمام. كل خطوة هنا تقودنا نحو تحقيق أهداف رؤية عمان 2040 التي تسعى إلى نظام تعليمي يتسم بالجودة العالية وينمي كفاءات عمانية ديناميكية قادرة على المنافسة في كل الساحات. طلبتنا هم أساس المستقبل، يجتمع فيهم الشغف بالمعرفة والطموح اللامحدود للابتكار. يعملون بتفان ليكونوا قادة في مختلف المجالات، يسهمون في تشكيل مستقبل أكثر إشراقاً. هنا في جامعة التقنية والعلوم التطبيقية يصقل كل طالب ليكون مؤثراً في مجتمعه، مبدعاً في مجاله، ومبتكراً يسهم في مواجهة تحديات العصر، حاملين معهم قيم النزاهة والتميز والتنوع، ومستعدين لريادة المستقبل بكل ثقة. الجامعة تفتح آفاقاً جديدة من خلال برامج الماجستير التي تعمق المعرفة وتوسع الآفاق. فهي لا تسعى فقط لتعليم الطلبة، بل لتمكينهم من الريادة في مجالات البحث العلمي والابتكار وريادة الأعمال. إن شراكاتنا مع المؤسسات المحلية والدولية تعد وتجهز طلبتنا لعالم متغير من خلال التعاون مع القطاعات المحلية والدولية. يحصل طلبتنا على فرص تدريبية تفتح أمامهم أبواب سوق العمل العالمي ليكونوا فاعلين في تحقيق أهداف التنمية الشاملة. جامعة التقنية والعلوم التطبيقية ليست مجرد مؤسسة تعليمية، بل هي محطة للتحول ورحلة نحو المستقبل. جامعة التقنية والعلوم التطبيقية، آفاق واسعة.
فائق الاحترام والتقدير لسعادة الدكتور رئيس الجامعة على كلماته القيمة ودعواته الطيبة لنجاح أعمال المؤتمر. يستضيف مؤتمرنا هذا باحثين متميزين من أعرق الجامعات العالمية مثل University College London UCL the UK, RMIT University Australia, and Link Shopping University Sweden. ويسعى إلى إتاحة الفرصة بين الباحثين والأكاديميين لتبادل الخبرات والمعارف فيما يختص بأحدث الطرق العلمية وآخر ما وصلت إليه المعرفة في سبيل البحث عن الحلول الناجعة لقضايا البيئة والتنمية المستدامة. The current edition of the conference hosted esteemed academic staff from reputable universities: University College London, UCL, UK, RMIT University, Australia, and Link Shopping University, Sweden, to enable knowledge exchange and sharing of the latest technological advancement. والآن ندعو الدكتورة مارليز إيفرتس المحاضرة بجامعة UCL لتقديم محاضرة بعنوان دور انتقال الحرارة بالحمل المختلط في الهندسة المستدامة، للتعريف بإسهامات الهندسة الحرارية في رفع كفاءة الطاقة وتقليل البصمة الكربونية في القطاعات الإنتاجية، فلتتفضل مشكورة. Now, let us listen to the first plenary lecture with the Dr. Marlies Everts, lecturer at UCL. Dr. Everts, the floor is yours.
Good morning, ladies and gentlemen, and thank you for the opportunity to give this lecture to you today on the role of mixed convective heat transfer in sustainable engineering. But before I delve into that, just a little bit of background. Today is not only a special day for me in terms of being here in Oman for the first time and giving this lecture. It's also today UCL's 200th anniversary. So today in London, they're celebrating, first of all, being 9th in the world according to the QS rankings for a number of years. We've been educating the students truly as a global university with 51,000 students and 400,000 alumni across 180 countries around the world. And we've been pioneering education, being in the front of innovation, as well as really putting back into the London community. So in the Faculty of Engineering Sciences, I'm hosted in the Department of Mechanical Engineering. And surprisingly, at UCL, we've been the first mechanical engineering department in England. So we've been teaching research for over 175 years, which is really a privilege for us. And in this, we've been educating students from about 1,100 students from 70 countries, over 150 dedicated researchers. And I'm part of quite a big and diverse department consisting of 60 academics, of which 28 are full-time or full professors. And we have 3 undergraduate degrees and 9 postgraduate taught MSc programs. So as an extension of UCL, we've about 3 years ago extended to a new campus, our UCL East campus in Stratford. And this is where I'm based in terms of research. I'm part of the Advanced Propulsion Lab, and I'm leading the thermal engineering activities as part of my group, which is the Efficient Thermal Engineering Group. So my research is basically focusing on 2 main aspects of thermal management. In the first category, I use single-phase cooling, mainly for indirect cooling, where I'm focusing on developing flow and mixed convective flow. Looking at the thermohydraulic performance, because that's how we can optimize heat exchanger performance. And then the second category of my research is multi-phase cooling, direct cooling, where I look at pool boiling, bubble dynamics, and I use surface engineering and different heat transfer fluids to again develop more advanced but also sustainable heat exchangers. So my today will focus mainly on the indirect part, where I bring together developing flow and mixed convection. So an overview of my talk today, I will start with some basics where I bring in the experimental research, looking at the general background of mixed convective flow, as well as the local Nusselt number behavior. Then I will bring in the CFD, which for me is the beauty of it, looking at entry lengths and boundary conditions, and then apply that so that we can see really what is the benefits of mixed convective flow, touching on flow regime maps, thermohydraulic behavior, as well as compact heat exchangers. So back to basics. When we open our heat transfer textbooks, we learn about forced convection and natural convection. So as the names indicate to us, forced convective flow, the fluid motion is forced by external means, whether it's a pump, if we push the fluid through a channel or a pipe, or whether it's a fan, where you force the air over a specific surface. However, the other side of it, known as natural convection, that means this fluid behavior is created naturally. There's no external means behind it. And this is basically due to temperature differences, which leads to density differences. And as we're operating in an environment in the presence of gravity, that leads to fluid motion. So near the heated surface, the fluid particles have a higher temperature and a lower density, and therefore naturally tend to circulate upwards, while the fluid further away has a colder temperature, a higher density, and therefore move downwards. So this leads to fluid motion, which on a low scale enhances mixing, but therefore also enhances heat transfer. But although we learn about these 2 extreme cases in our textbooks, the reality is that in practice, we cannot uncouple these 2 mechanisms. We need to combine them, and that is known as mixed convection. So this is typically what happens inside the tube. As I said, the fluid particles near the heated surface tend to move upwards. In the center, it's cooler. They move downwards. It creates 2 circulatory vortices, which enhances mixing along the tube length and therefore improves the heat transfer. So we use the Grasov number to quantify these effects. And as you can see here, the Grasov number is a function of the surface fluid temperature difference. So if we can increase this temperature difference through increasing the heat flux, we can increase the mixed convective behavior. But then it's also a very strong function of diameter to the power 3. So if we can increase the diameter a little bit, it can therefore significantly increase our heat transfer performance. So I spent a lot of research over the past decade looking at different heat fluxes and heating conditions, as well as diameters, to better understand this thermohydraulic behavior of mixed convective flow. And this graph basically summarizes a set of experiments and the effect of tube diameter and heating conditions specifically. So at the bottom, we have the smallest, in this case, results for a diameter of 4 millimeters, different heat fluxes. Then we have in the middle the stars. We have a slightly higher diameter of 11.5 millimeters, and then at the very top we have the 19 millimeter tube results. So this gives us the Nusselt number as a function of axial position, and it basically explains to us how the heat transfer coefficients will decrease from the inlet towards the outlet of the tube. So as we expected, an increase in diameter led to increased heat transfer coefficients. But then also, if we look at a specific group, so for example, we look at the 11.5 millimeter results, we see that as we increase the heat flux, again, we increased the heat transfer coefficients, which is kind of what we expected. But when we look closely to the trends in these graphs, distinct regions and behavior were identified, and based on this, I then developed this summary, which got, hopefully in an easy way, explain and summarizes to us what mixed convection do to the local heat transfer behavior inside tubes. So at the bottom, we have the red line, which is our force convective results. So that's typically the trend you will see if you open most heat transfer textbooks. Then the blue, green, and yellow lines are the lines you won't necessarily find in your textbook. That shows us the effect of mixed convective flow. And I've identified or named 3 different regions. Near the inlet is the force convective developing region, and the reason why I've called this force convective is as the fluid enters the tube, the thermal and hydraulic boundary layers need to start developing. So they are really very thin. There's no space really for mixed convective behavior to be significant, and therefore all the results, irrespective of Grashof number, tend to collapse onto a single line. However, when we move further along the tube, then we enter the mixed convective developing region, and as the name suggests, the boundary layer thickness now starts increasing. There's more space for these convective currents to start developing, and as they develop, they promote mixing inside the tube, and therefore our local heat transfer coefficients no longer decrease, but they actually start increasing now, enhancing the heat transfer inside the heat exchanger. Then once the flow becomes fully developed, the heat transfer coefficients becomes independent of axial position. However, it still increases in magnitude with increasing Grashof number. And then a small detail in this graph, but it should not be overlooked, is this boundary between the mixed convective developing region and the fully developed region. Because as we look from this graph, we see that it inclines to the left as we increase free convection effects. So this tells us something very important, and that is that the hydrodynamic and thermal entrance links, as we see them in our textbooks, can not only be a function of Reynolds number, Prandtl number, and tube diameter. When dealing with mixed convective flow, which we basically find in all our heat exchanger applications, we also need to account for the Grashof number. And it was at this point when I then started bringing in CFD investigations to complement my experimental results, and that's when I really discovered the beauty of mixed convective flow. So I started off basically where I finished or just paused the experiments for a moment. by having a look at these boundary layer developments in more detail, because now I was able to really look into the tube and see what is happening. So as a starting point, looking at force convective flow, it was typically as we would expect from our textbooks. The black is the hydrodynamic boundary layer, the red is the thermal boundary layer. As the flow enters a heated tube, these two boundary layers starts developing and they merge in the center of the tube. So that's good, confirmed, but now what happens for mixed convective flow? And then the two cases, the top is for a very, quite an average mixed convective case, and then the bottom graph is an order of magnitude higher mixed convective case. And as we can see now, all of a sudden, what we've learned in textbooks is not really what we're dealing with in practice, and we need to better understand what's really happening inside our heat exchangers. So if we start with a hydrodynamic boundary layer, which is the black lines in this case, we see that for both forced convection and mixed convection, it merges in the center of the tube. However, when we increases the mixed convective conditions, this point occurs earlier inside the tube. But then the big difference is that this point does not stay constant. It actually decreases, increases slightly, and then only become constant and thus fully developed much, much later along the length. So what this tells us is this mixed convective behavior, which is really favorable from a thermal perspective in terms of mixing, is actually disturbing the flow development and is delaying the flow to become hydrodynamically fully developed. And we need to pay a price for that, which is increased friction factors, pressure drop, and thus pumping power. On the other side, if we look at the thermal behavior, so now we're shifting to the red data, we see that, yes, for forced convection, it merged in the center of the tube, but for mixed convection, it actually shifted below the center line of the tube, and then this point shifted further downwards before the flow became fully developed. But now we're seeing the opposite trend as for the hydrodynamic boundary layers, whereas if we increase mixed convective flow with an order of magnitude from the top to the bottom graph, this point at which the flow became fully developed actually occurred earlier along the tube length. So based on this, I developed two correlations that can better predict the hydrodynamic and thermal entrance lengths. And I developed it in such a way that the first part basically represents forced convective conditions, and the second part accounts for mixed convective behavior. For the thermal entrance length, there's a minus sign because mixed convective effects actually decreased the thermal entrance length, while it disturbed the hydrodynamic development, and therefore it extends the hydrodynamic boundary layer. Now, the beauty of these correlations is that when the Grasov number tends to 0, these correlations automatically tend to the forced convective correlations. So irrespective of whether you're dealing with forced convective or mixed convective behavior, these correlations can be used. I then also went into a little bit deeper and looked at the streamlines and the thermal behavior inside the tubes. And as we can see here, the dotted lines, just for reference, represents the center line of the tube. We can see that the vortices, which is basically our secondary fluid motion, as it developed and became stronger, it moved downwards and towards the sides of the tube, which also explains to us why those merging points developed below the center line of our heat exchangers. So as we can see here, it starts very nice in the center of the tube, then it moves downwards, and then a slight upwards before becoming approximately constant. And likewise, with the thermal boundary layer, this merging point which is indicated by the red dots, first move downwards and then it becomes approximately constant. So the researcher in me was then curious, okay, so if this is happening with the constant heat flux boundary condition, what happens if we now change the boundary condition to a uniform wall temperature? Because again, this is the two cases that we deal with in our heat transfer textbooks. And as the name suggests, when we're dealing with a uniform heat flux boundary condition, the surface fluid temperature difference becomes constant once the flow is fully developed. Now, because this is constant, we can expect constant Grashof numbers and therefore constant mixed convective behavior, as we've seen in the results up to now. However, when we change the boundary condition to a uniform wall temperature boundary condition, and this is actually typically the boundary condition we deal with in most phase change heat exchangers, because the moment it involves boiling and condensation, we're dealing with this kind of temperature profile. We can see that this surface fluid temperature difference is almost never constant. And because that is not constant, our Grashof number can't be constant, and it tells us that our mixed convective behavior is continuously changing inside the heat exchanger, and we need to know how we can benefit from it in order to improve our heat exchanger performance. So similar to the previous one, I've had a look at the streamlines and the temperature profiles inside the tubes, and it looks more or less the same. However, you would see that now the streamlines are much more symmetrical, which is good, but it's also not that good because it tells us that mixed convective behavior is quite suppressed in this case. And again, dotted lines just for reference where the center line is. We can see that this merging point, although it developed quite below the center line due to mixed convective effects, as the flow further developed, it moved back and very much to the center line. So you might at this point think, okay, but what's the big deal of it? Because we still have temperature gradients, so we still have this convective behavior going on. But it should be noted that this is the local temperature ranges. So it basically just looks at the local temperature range at this specific cross-section. If we plot this in terms of global temperature ranges, we see that towards the end of the heat exchanger, there's a very negligible temperature gradient, and therefore we can no longer benefit from any of these mixed convective effects. So it's very important when designing a heat exchanger to understand with which boundary condition you're mainly dealing, because that can tell you whether you should aim for a much longer heat exchanger or should you just not worry about it and rather go for a shorter heat exchanger when dealing, for example, with the uniform wall temperature 1. Because near the inlet of the tube, it behaves quite differently. But towards the exit, that's when we really see the differences, where it becomes constant and significant for a uniform heat flux boundary condition, whereas for a uniform wall temperature boundary condition, we basically lose all of this mixed convective power. And what's happening in terms of the boundary layers directly impacts what is happening inside in terms of our heat transfer coefficients, and that's what we're fully dependent on. So irrespective of which boundary condition we're operating with, near the inlet of the heat exchanger, the trends are quite similar. It decreases from a maximum as the flow develops, then it increases when the mixed convective behavior kicks in and starts to become dominant. But then after a certain point, it can maintain this mixed convective effects when we're dealing with a uniform heat flux boundary condition, but we completely lose this power when we're dealing with a uniform wall temperature boundary condition. And then the longer our heat exchanger, the smaller the temperature difference will come. So we're dealing with laminar flow and forced convective conditions. Yeah, with this difference of a factor of 1.2, and you might ask, what's the big deal about it? However, when we can deal with mixed convective flow, there's a factor very easily of at least 2.5, and that's really important in terms of heat exchanger efficiency. So understanding the fundamentals of it then just put me in the position to start looking at how we can benefit from this in our heat exchanger designs. And I therefore developed this flow regime map, which is basically an engineering tool we can use to, within seconds, determine in which flow regime we're operating, whether there's free convection effects or not, as well as with what heat transfer coefficients we can expect. So it's not just a colorful picture, it's really a very handy tool and kind of our first step towards heat exchanger design. So how it works is we have Reynolds number, which categorizes our flow regimes and our velocity on the y-axis. On the x-axis, we have Rayleigh number, so it's the Grashof number multiplied with the Prandtl number. So it really accounts for different heat transfer fluids as well as the mixed convection effects. And then in the blue areas, that's where we're dealing with forced convective flow. So the general information you will get readily available in all textbooks, whereas the colorful regions, that's when we're really focusing on the mixed convective behavior and see what enhancement we can get through this. So at the bottom, we have forced laminar, mixed laminar, in the middle, forced transition, mixed transition, and then at the top, the forced turbulent flow regime. So say, for example, we have a heat exchanger, and we know that in this heat exchanger, we're dealing with a Reynolds number of approximately 1,000 and a Rayleigh number of 10 to the 5. We can quickly go and locate this point on our graph, and then we see, okay, it's more or less there where the color changes to cyan, and then looking at the color bar, we see, okay, that's a Nusselt number ratio of approximately 2. We have our forced convective reference, which is 4.36. If we substitute it in there, we have a Nusselt number of approximately 8.7. So without any complicated correlations, which is prone to typing errors or calculation errors, lengthy steps, within a few seconds, we knew we had to account for mixed convective flow. We knew it was laminar flow, and we also have an estimation of the heat transfer coefficients inside our heat exchanger. And this is basically just showing the effects of the Grashof number if we increases the heat flux from approximately 4 average Nusselt number to easily Nusselt numbers of 12, which is a significant heat transfer enhancement. I then also developed, if you focused on accuracy, correlations that can be used in each of these flow regimes. So for the laminar flow regime, transitional flow regime, turbulent flow regime, and then a summary, one correlation that summarizes everything for us. Then looking at the thermohydraulic behavior is very important to us because we can't only look narrow-minded on heat transfer coefficients, we also need to look at the pumping power. And that is what we do within our friction factors through simultaneous heat transfer and pressure drop experiments. And as we can see here, with mixed convective flow, we were able to give a bigger enhancement in heat transfer than the price we had to pay in terms of pressure drop, which led to lower FJ factors and thus improved thermal hydraulic behavior. When dealing with thermal management, we have this tug of war going on all the time, where on the one side, we're pulled towards militarization, and then on the other side, we continuously need to increase our performance. And for that reason, we often go towards smaller channels to increase the power density and the surface to volume ratio. And I therefore also then started looking at non-circular channels to understand, can we compress this mixed convective behavior in a more compact way and still benefit from it? So again, looking at different diameters, different aspect ratios. In general, an aspect ratio of a half gave best results, but then further along the tube length, we all of a sudden had this spike in heat transfer coefficients, which was quite interesting for us. And then an aspect ratio of 1 started outperforming it. And to understand that, again, looking at what's going inside, we saw that as the flow developed, the vortices developed, but then all of a sudden we had the secondary vortex pair developing due to this increased bottom heat transfer surface, and this significantly enhanced the circulation strength inside the tube, which spiked up our Nusselt numbers and therefore increased our heat transfer performance. So to conclude, mixed convective flow, although it's kind of underrated in our textbooks, it's very important in our everyday heat exchanger applications. It enhances our heat transfer, but it also affects our hydrodynamic and thermal entrance links, and that's why flow regime maps are really helpful to predict its significance. And we can increase this heat transfer by increasing the diameter, heat flux, temperature difference, as well as the aspect ratio. And we can still benefit from this in compact heat exchangers, and we can enhance this further through surface modifications. And then just a quick note, as Associate Editor of the International Journal of Low Carbon Technologies, I would like to invite you to just scan the QR code and have a look at our journal. And I thought, especially for the audience today, it might be worth addressing your attention to these two special collections, which is currently ongoing with deadlines in March and May. And with that, I just want to thank you again, the organizers, for inviting me and the opportunity to speak to you today.
Thank you, Dr. Everts, for the presentation. شكرا جزيلا للدكتورة مارليز إيفرتس على المحاضرة القيمة. ومن الهندسة الحرارية ننتقل إلى محور آخر للمعرفة الإنسانية، وهو سلاسل التوريد وهندسة اللوجستيات والعمليات نستمع الآن إلى محاضرة بعنوان الذكاء الاصطناعي ومرونة سلاسل الإمداد العالمية، تداعيات على الاقتصادات الناشئة. يقدمها البروفيسور فيكتور جيكارا من جامعة RMIT University ليحدثنا عن التنوع الاقتصادي واللوجستيات الخضراء وخفض الانبعاثات في منظومة التجارة والنقل، فليتفضل مشكورا. From thermal engineering, we now shift to another visual discipline, supply chain, logistic and operations. Professor Victor Jikara from RMIT University will present a talk on AI and global supply chain resilience, focusing on economic diversification and green logistics. Please welcome him. Professor, the floor is yours.
Good morning, ladies and gentlemen. And just like my colleague that just finished speaking, I am very grateful for the invitation to present at this esteemed conference. My name is Victor Gikara. I'm a professor of supply chain and logistics management at RMIT University in Australia. When I was invited to speak at this conference, I scratched my head to try and see what is it that I could present that would be of benefit and interest and that would align with the name and the focus of the conference. And that was not very easy because the kind of research I do is significantly different from what my colleague, for example, presented. However, I am not going to present any particular project. I'm going to present a much more organizational view of supply chains and the role that enhancing technologies, including and predominantly including AI, are playing in the future of supply chains and national economies, but also reflecting on the nature of the nation state. Now, before I start, ladies and gentlemen, I just want to give you an idea of the kind of research that I do so that we can put my presentation in some sort of perspective. Although I am a professor in supply chain and logistics management, my research discipline home is actually sociology and political economy, to be specific. So I look at, over many years, I've looked at the ways in which that governments, nation governments, try to manage the resources in the economy in order to achieve the best outcomes for that economy. And I have looked at developments such as industrial restructuring, so the growth, the disappearance, the emergence of new industries and occupations and activities. I have looked at organizational change, the ways in which organizations change and how they adjust that change, and the kind of forces that influence those changes. And I've looked, in recent times, I've been focusing on the ways in which technology, new technologies, including AI, are impacting and influencing the way organizations change and how production and supply chains operate and what that means for the future of national economies, including the automation of work and what that means for workers' health, safety, occupational health and safety, well-being, and their skills. So the implications for this, obviously, is to look at the ways in which industry skills demands change, the ways in which workforce training needs are organized and managed, the ways in which the nature and texture of work changes and the experience of the same. And I also look at workplace inclusion, well-being, etc., etc. So that's the kind of research that I do and that I reflect on. So my presentation today is based on very keen observations of the developments that are happening in supply chains particularly, very keen observations on the ways in which governments and industry organizations are responding and what that means for the future of supply chains. So the focus today, ladies and gentlemen, is threefold. So I am going to touch on what advanced technologies, i.e. AI, and I talk about advanced technologies more generally, but AI, obviously, as we understand, underpins and increasingly underlies most of the advanced technologies we are talking about. So when I talk about technologies and advanced technologies, I'm also talking about AI and vice versa. So I'll talk about advanced technologies and what that means for supply chain sustainability and resilience. I will talk about the benefits of the emerging technologies in terms of efficiencies, visibilities, and circularity of production. I will talk about the risks and externalities, the challenges that are involved or associated with the changes that we are talking about. I will talk about the role of the state, and I will reflect on the ways in which predominantly smaller states, developing and emerging states, can make better advantage of the changes that are happening and the new technologies. So some of the subjects that I teach supply chain technologies. And in this, I invite my students to reflect on the kinds of technologies that are predominating the landscape that we are talking about in supply chains. I invite them to reflect on the sustainability implications and questions of these technologies. And I also invite them, because obviously I am from the international political economy perspective, I invite them to also reflect on the ways in which governments and nation states can benefit from these changes, but also at the same time, how they can better manage the negative implications of the new technologies. So some of the technologies that obviously, as you will know, that are significantly underpinning the changes we are talking about would include AI, artificial intelligence and machine learning, IoT, Internet of Things, digital twins, a big thing in supply chains at the moment, robotics and blockchain. And I'm going to look at sustainability from a much broader perspective, not just environmental sustainability, but I'm also going to reflect on social and economic sustainability, because all this, we need to strike a balance in order to talk about effective sustainability at the end of the day. Resilience, I'm talking about the ability of the economy, the government, the country to be able to absorb, adapt, recover, and transform along the opportunities that are presented by new technologies. Now, why is this important at the moment? We all understand or have come across statements that indicate the exponential and significant improvements and advancements that are taking place in the innovation space. We have seen many statements coming from very prominent figures in the political, economic, and academic space about the likely implications and impact, how huge, how the scale of that impact is likely to be over the next few years. So there are significant changes taking place in the innovation and advancements of technology. AI is one of those technologies that is being spoken of as the game changer that is going to change everything as we know it today. I mean, we've got prominent technology innovators themselves coming out and making statements that indicate or suggest that, almost suggest that the very product that they market to the industry is probably a danger to the future of economies and nation states. And Elon Musk recently describing AI as an existential threat to our civilization. So the pace, the rate, and the scale of technology advancement is so significant that this becomes an important moment in time when we have to reflect upon what is it that we need to do as a nation state, as an economy, to be able to grow with these technologies and not compromise the sustainability questions along the way. Data abundance, then the availability of data and the enhancement in computational powers is another factor that means that we need to talk about this at this particular moment. And I'm glad that this conference particularly has chosen to focus on this topic. This is also compounded by significant global disruptions. If you look at what happened during the pandemic, suddenly we come to the realization that the way that we've done things, run the economies, managed global supply chains is significantly inadequate or needs to be revisited and redesigned. Global industrial restructuring. Now, what is happening with advanced technologies and the supply chains, production systems and patterns globally as different from what it was in the 80s and the 90s, when there was massive shifting of industries overseas to benefit from lower wages and availability of skills. What we can see now in terms of a global perspective is that most of these industries are reshoring. So where the likes of the Czech Republic, the likes of Thailand were becoming significant production locations, for example, for the automobile industry, we are seeing a lot more resurgence of economies like the UK and the US and others because of the reshoring. Now, because of automation and artificial intelligence and other significant advanced technologies, there is probably not much need for that offshoring of production. Now, what does that mean in terms of how smaller states, or states for that matter, respond to these changes that are driven by advanced technologies? There is also increasingly investor pressure. There is also increasingly public pressure. There is also increasing regulatory pressures for governments and economies to act in a way that ensures the sustainability of economies and supply chains going forward. So that's why I think that it is important to speak about AI, advanced technologies, and the supply chain and the future of that supply chain and national economies going forward. Now, the common hypothesis for AI, supply chains, and the future is that AI is obviously improving productive efficiencies. AI is reducing the cost of production. AI is enhancing the scale of productivity. And because of all this, and there's also, obviously, we have to admit that to some level and some extent that we probably need to continue studying and understanding, AI is enhancing our ability to manage sustainably the use of resources, national resources, energy, water, etc., etc. Now, this is meant to lead, at the end of the day, to highly positive outcomes in terms of economic sustainability, environmental sustainability, and social sustainability. That is the general hypothesis. That's the common hypothesis. But at the same time, at the end of the day, we have to ask ourselves, what are some of the challenges? And I think, as the introduction at the beginning from the president of the university, we have to weigh the balance between the externalities and the positives of advanced technologies if we are to make the best out of it. So this is really just an illustration of some of the ways that AI impacts upon our supply chain. So from a logistics perspective, you're talking about significant logistics optimization. So cutting cost, enhancing efficiencies, and enhancing that productivity of every organization involved. Waste reduction. Because of all this accurate planned and forecasting in production, you are able to minimize the waste production along the line. Enhanced visibility and compliance. For a long time, global supply chains were opaque in a sense that if you talk about ethical and social issues, employment and labor issues, you can only see as far. You can't see beyond that. And therefore, a lot of the ethical concerns that were involved in this were not visible to the main buyers in the market. But now with technologies like blockchain, we have that visibility, and therefore we are able to enhance compliance along the supply chain. Energy demand prediction. If we are able to predict, we are therefore able to manage much more effectively the utilization of energy, the consumption of energy, and therefore ensuring future sustainability of energy demand and consumption. And all this, ladies and gentlemen, is enabled by advancements in AI, because we are able to compute all this massive data that we have to make sure that we are able to benefit our economies. Sustainable sourcing, that ties in with the point that I've just made about the opaqueness and the long supply chain, and why it's important to be able to see as far as the very source of the raw materials and the resources that we are using, and all the practices that are taking place along the supply chain. However, let's look at the key challenges. There's a catch-22 here. And the catch-22, for me, this is very important. That the balance that I talked about, the benefits and the externalities of AI and advanced technologies. So I created this. Maybe it makes sense, maybe it doesn't make sense, but it does make sense to me. That to save the world enormous energy, water, and other resources by AI needs enormous amounts of these resources. So then how do we manage this situation? So there are externalities that I'm going to touch on. I'm going to talk about resource externalities. I'm going to talk about social externalities, and I'm going to talk about economic externalities. And some of the resource externalities include the high demand for energy, electricity, in order to power AI, the AI production, AI use across the world. The high demand for water, for example, to cool the enormous servers that have to generate this computing power that we are talking about, that drives global supply chains. There's also the question of how do we dispose of all the e-waste that is generated by the advancements we are talking about. There are also the threats, and lately we've seen the emergence of the threat of the seabed mining for rare earth minerals. What exactly is that likely to lead to is something that we need to ask ourselves. Now, to be very clear, I'm not a predictor of doom when it comes to technologies. I'm simply saying that for countries that are emerging, countries that aim to take a much more competitive role and place in global supply chains, we need to think about these things a lot more seriously. We need to weigh the benefits against the challenges and the sustainability issues that we are likely to face. The second set of externalities are social externalities. The global digital equity and inclusion. Now, as governments manage the growth of the economy, the prosperity and the generation of wealth through global supply chains and enhancing technologies, we need to make sure that the inclusion, the exclusion are all questions that we address effectively to ensure that it's equitable access to technologies, equitable access to all the benefits of prosperity in the economy. There's a question of labor displacement. Now, this is a debate that has been going on for a very long time, ladies and gentlemen. From the 16th century, Queen Elizabeth I, lamenting how the invention of the knitting machine was going to destroy jobs for her people and render them beggars and destitute. That's what she said way back in the 16th century. To the 19th century, when we've got the Luddite uprising, exactly about the same thing. The new technologies and what it means for employment, what it means for work, what it means for livelihoods of people in society. These are debates that have been going on for a long time. To the most recent, where you've got the great academics like Keynes talking about technology as the new disease that is going to be difficult to manage. Thank you. Now, the point I'm making here is that although these are not new debates, they are significant debates. We have to ask ourselves, are we in jobless growth? Are we engineering jobless growth? Or are we actually consciously and deliberately thinking about how we advance the economy, but at the same time advance the well-being of societies and the people within it? Economic externalities would be global inequities. We are talking about smaller states and how there is the danger and the threat of being left out of the big technology machine that is happening. How small businesses, small to medium businesses, which to predominate smaller states, are likely to suffer if they are not effectively included in that growth. So let me come now to the question about the nation state, the complex dynamics of AI, global supply chains, and the role of the nation state. And I think that the nation state is not only the facilitator and manager of global supply chains, but it's also actually a part and component of the supply chain itself. So in the global arrangement, the global dynamics of the supply chains, the state is an interested party, but at the same time, the state is responsible for managing and regulating the global supply chains. And at the end of the day, if we are saying that AI is going to significantly impact the global supply chains, then we have to ask, what is the capacity of the state to effectively manage the deployment of that AI and advanced technologies to benefit the country in the way that it should? So here we can see that on the one hand, the state has got its own independent needs alongside the needs of the society and the needs of business. But at the same time, on the farthest end, you can see that the state is as the center of managing all the interests of the other parties involved. So you talk about the state having social priorities, sustainability priorities, and economic priorities. So the state has to manage and think about how to enhance all this as it progresses with new technology. Now, there are different challenges, and one set of the challenges is the technological challenges for smaller states, particularly smaller states and emerging states. The question of what are the strategies in place? How do we enhance research and development by facilitating conversations like this and resourcing the growth of domestic technology capacities? How sound is the digital infrastructure? These are some of the questions that the state has to ask itself. How strong are the national standards to regulate the deployment of the new technologies? Secondly, we've got the socio-economic challenges for the state. And the questions here include, is the workforce adequately skilled? What are the associated employment threats? I've talked about the employment threats. What are the likely occupational safety risks that are involved for the workers and the general population, and how to prevent potential modern-day slavery risks around the use and the deployment, the development of AI for that matter. There are also environmental challenges that the state has to think about. What are the socio-economic and environmental implications of AI? Those are significant questions. What are the necessary, appropriate, and viable mitigations that could be put in place to manage the situation? So the regulatory challenge for the states is how to effectively regulate the adoption and deployment of these technologies, and the question of do existing regulations and regulatory frameworks actually adequately address the changes that are taking place. Now, the key, as I head on to the conclusion, the key for smaller states, the key questions and key concerns for smaller states, ladies and gentlemen, include infrastructure and technology barriers. Inadequate infrastructure, how do you invest in inadequate infrastructure? Legacy systems that are out of date, how do you integrate new systems on top of legacy systems? Data quality and standardization. Financial and economic constraints are another big challenge for smaller states. High initial investment and questions about returns on investment, because it costs a lot to initially develop these technologies. There are also workforce skills and expertise shortages. So you talk about skill shortages, the possibility of employment displacement, and the question of what do you do with the displaced workers that come out of the economy in that situation. You've got questions about data security and ethical risks, data privacy and sovereignty, biases in information, bias in misinformation. Now the question we need to ask ourselves is, if for smaller states that is, if most of the technology is developed and on the basis of frameworks of developed countries, how does that reflect our needs as smaller states? And do they represent our interests? Geopolitical and competitive pressures are another challenge that we need to think about. And finally, institutional regulatory and regulatory gaps. So for example, lack of clear regulations and distrust in data sharing. All these are questions of significance that smaller states have to ask themselves in order to ensure that the use of the development, deployment of new technologies, including AI, are of greater benefit to those economies than the disadvantages, and how to manage the externalities of the technologies in the global supply chains. Once again, thank you very much, ladies and gentlemen, for listening, and thank you for the organizers for inviting me to speak at this great conference. Thank you.
Thank you, Professor, for the valuable talk. شكراً جزيلاً بروفيسور على المحاضرة القيمة. والآن نتشرف بدعوة الأستاذ الدكتور محمد صاحبي الوكيل من جامعة لينك شوبينج بالسويد لتقديم محاضرة بعنوان تصميم وأداء المواد المركبة المستدامة لتطبيقات الحياد الكربوني في المجالات البحرية والفضائية. فلتتفضل مشكورا. The third session will be with Dr. Mohammed Wakil from Linköping University, Sweden, to talk about design of sustainable composite material for carbon neutral application in the marine and aerospace sector. Please welcome him.
So good morning, everyone. It's my great pleasure to be here today, and for that reason, I would like to thank the organizing committee for inviting me and giving me the chance to give this talk today. So thanks a lot for the nice introduction. So my name is Mohamed Loukil. I am originally from Tunisia, but I have been in Sweden for about 14 years, working on materials for sustainability. And what I'm going to talk about today is how we use sustainable materials for both marine and aerospace applications. So this picture was taken on Monday morning before I left Sweden. So you can see this taken from my window in Sweden, and you can see the white color covering the whole country now. It was -9 when I left Sweden. Coming here, enjoying the nice weather, very nice and beautiful country. So getting plus 30 degrees almost, from -9 to plus 24. So Linköping is located about 200 kilometers south of Stockholm. And this year we celebrated the 50 years anniversary of the university. So we have about 30,000 students studying at the university, 4,000 employees, and a little bit more than 300 professors. So we have about 12 departments. And what you see in the picture, that building actually is department. Each department is presented by one building. So the whole campus actually contains about 12 buildings, and it's a huge campus in Linköping. So we are actually among the top 2% in the world in international university rankings, and we do research across boundaries. And you can see there the 4 faculties that we have. So we do activities and research and teaching as well in art and sciences, educational sciences, medicine. And the last faculty is science and engineering, and this is where I work actually. And my division called Engineering Materials, and this is a picture of my colleagues at the division. So we are about 20 researchers in total. We have about 7 between associate professors and professors, 6 postdocs, and 7 PhD students. And what we do actually, we focus on mechanical testing and material characterization. So we work on different materials, so we try to link the microstructure of the material to the properties. So we work with metallic materials, we work with polymer composite materials, and additive manufacturing. And we have actually a lab with many equipments that help a lot to investigate the microstructure and link them to properties of the material. So today, I picked 2 topics that I will present to you. The first one is about marine and how we can make the marine sector, like boats, more sustainable. And the second topic will be about aerospace, and there I will focus more on hydrogen as net zero, actually, application that I will focus on. But before that, since I will talk about sustainable materials and more specific composite materials and how we can use composite materials to make these two sectors more sustainable, I will just give a short and brief introduction to composite. So what is this material? So usually composite is a combination of two different materials. The first one is fibers, and the second one is a matrix. So the fibers usually, they are very strong, very stiff, so they have a very good properties. But to glue the fibers together, we need to add the matrix. So the matrix is like a glue that we use to bind all the fibers together and make a component or a product. So the composite material, it is usually used in different sectors, like the aerospace. So the Boeing 787 contains 50% of the total structure is composite material. It is used a lot in the wind energy. So wind turbine blades, they are made of composite material, almost 80%, sport cars, and many other applications. But the question is why we use composite material. So composite material, it's a very light material, but it has a very strong properties. So we talk a lot about sustainability, and we want to use more sustainable materials. And for example, if you have a heavy structure moving, like a car or an airplane, to make it more sustainable, one of the options that we have is to make it lighter. So if we make an airplane lighter, it means that it will consume less fuel, and it means that the CO2 emission will be less. So for that reason, composite material is the best material actually to use to make the structure very light. So it can be a car or it can be an airplane. So every structure which is moving, so to make it lighter, to consume less fuel, we can replace heavy materials like steel with composite materials. And actually also these materials are corrosion resistant, so we don't have any problem with corrosion. We can also tailor the properties of these materials. So we can put more fibers in the direction where we have a load to get the structure stronger in very specific directions. So now I will talk about the first topic, which is using those materials for marine application. So we have this boat. There is a company in Sweden called Shore. They are making 100% electrical boat. And this boat actually is made from two types of fibers. So this is, we call it carbon fiber, the black one, and the white one, we call it the glass fiber. The problem with those fibers, they are not sustainable. To make those fibers, they go through a lot of chemical reactions in the lab, high temperature, high pressure, and so on. So we wanted to use a more sustainable material. And one option is to use what we call them natural fibers. So fibers just taken from the forest, from the trees. And the question is, can we use these fibers and make the boat more sustainable? This is what the company wants. They want to show that their boat is 100% electric, but also it's made from sustainable material. Those fibers, they have problems. They absorb water. So if you make a boat directly from those fibers, they will just degrade and absorb water. So we wanted actually to help this company to use more sustainable materials in a smart way and reduce their sensitivity to water and humidity. So one of the options that we have is to coat these fibers with graphene. So make some treatment to those fibers and check how the sensitivity to water and humidity will change. So we did a study from micro scale to macro scale level. So we started working with like lab scale to a demonstrator at the end that we manufactured. And we did some material selection, manufacturing, testing, and material characterization. And what you see on the top in the picture, this is the fabric or the fibers that we use. We use a fiber that we call it flax fiber. And what you see on the bottom side is the fibers after coating them with graphene. And how we coated them, we had a partner in the project. It's a company in Sweden. They are expert in coating fibers for thermal conductivity. So it was their first project working with natural fibers. So they used to work with glass fiber for thermal conductivity. And what they do, they prepare a solution with a graphene, so it's like ink, and they put the fibers in them, in the ink, and then they dry it, and then it becomes coated. And they have done a great job, so the coating was perfect. So we had three suggestions in the project. So first we made a part which is with flax fiber, natural fibers, and coated. And the second option, we just coated the top and the bottom layer because we thought that this actually can protect the inner layers from water and humidity, so the water will not go inside the boat. And in the third option, we coated the whole structure. So all the material that we use, it was coated. We use a flax fiber. We use a bioresin. So the glue was a bioresin. We use a method that we call it vacuum infusion, and I will show you later how this method works. And we did all needed investigations at mesoscale level, so at the lab, and also for the demonstrator. So we applied many mechanical testing which are needed to approve that this material can be used for marine industry. We also did water absorption. So we put the structure that we built in water as well to check how much water it will absorb if we coat the fibers. So this is the method that we use, vacuum infusion, how it works. So we have the resin going inside the layers that we put. So first we took, maybe I show you this video. So first you have the layers, the flax fibers, the natural layers there, and we have the resin going inside, and we have that tube, which is horizontal tube, it has some holes. So the resin will propagate inside the whole fabric. So this is a simple geometry, flat geometry that we made, but also we manufacture a component using this method as well. And then the resin covered the whole area along the length and the thickness. So after that, we did testing. The first test that we did was water absorption for 1 month. So we put all the parts that we manufactured in water, hot water and salted water, for 1 month, and every day we were weighting the structure and see how much water it absorbed. And as you can see here, so you have in percentage how much water they have absorbed, and we didn't see big difference. So the black curve actually there is showing the no-coated product, and the green one is showing the component where we coated both layers on the top and on the bottom. And the last one, the green curve, is showing the structure which was fully coated. And we noticed that coating natural fibers with graphene, it will not help a lot in water absorption. Then the question was, why? But we did some analysis, and as you can see, the fibers which were not coated, they have degraded. However, the ones which were coated, they were not degraded. So the structure was still okay, but they absorbed water. And it's almost the same quantity, about 7% they absorbed in 1 month. So then we had the question, why? Why it didn't work? And we noticed, after discussing with all the partners in the project, that the company who did the coating, they applied the same process that they are using to coat fibers for thermal conductivity. This was their first project with natural fibers to improve mechanical properties and resistivity to water. So then also we said, okay, maybe there is a problem with the coating process. We have also performed some mechanical testing to check the properties, and we noticed that after putting the component in water, the dotted lines, the actually properties goes down. So it means that we cannot go further with this type of coating. And we didn't see any increase in properties after coating. So then we decided to investigate more this topic. And what we did, we asked the company to coat with different concentrations the material. So what you can see here 0%, 0.5%, 1% is 1.5% is the concentration of the graphene that they use in the ink before coating. So they prepare different solutions with different concentrations, and then we coated the material. And that actually was helpful because that was the problem. So when they did coating for the first time, they have already a certain concentration that they use for thermal conductivity and not for natural fibers. So the results, they were different. What I am showing there is the strength of the material as a function of the strain. And as you can see, at 1.5%, we have a very good improvement of the properties. We also saw similar results when we did water absorption. So the material which was coated at 1.5% absorbed less water. Then we decided from that point to use 1.5% as optimum coating. We have coated actually the material with higher than 1.5%, but it didn't show good results. So there is an optimum value where from where the coating, if you increase that concentration a little bit more than the optimum value, then the properties will go down again. So for that reason, we decided to keep 1.5%. We did also some SEM to understand, so scanning electron microscope analysis to understand what is happening in microscale level. Why we didn't get good results when it's 0.5% concentration. And it showed that actually, when we did the coating with this concentration, the graphene flakes, they were not covering the whole area of the fibers. However, at 1.5%, the fibers, they were very well coated, and the graphene was covering the whole areas. So we made this part in the lab. The top part is the boat. So we used the metallic mold, and we made it using vacuum infusion. What you see on the top is the uncoated part. What you see on the bottom side is the fully coated part. And we put them in water also for 1 month, and we observed that the coated fibers absorb 40% less water than the uncoated one. So this is something that we have analyzed. We got also the question about sustainability. So when you take a natural fiber itself, it's very sustainable, so it can degrade after using it. But what about the fiber if they are coated with graphene? Are they still sustainable? So we did some analysis. So this is some tests that you do according to standard. And you can see for the uncoated fibers, they disappear almost after 42 days. But the coated ones, they are still there, but they need more actually time to degrade. So they are still biodegradable, but they need a longer time. So we are still ongoing with this experiment, but they are actually degrading. So we learned a lot from this project. So coating natural fibers with graphene can work, but you need to understand the optimum concentration that you have used. You need to understand better the process, how you do it, how much time you have to put the fibers in the ink, how much time you have to dry them, and so on. Another option that we have thought about is chemical treatment. Maybe we need to treat the fibers before putting them in the ink, because when you put them in the ink, they can absorb also water, because the water or the ink is based on water. Third option that we are thinking about also is the manufacturing method. Maybe vacuum infusion is not the best, and we are also addressing more manufacturing methods. So the next step in this project, now, we are going to make the hull of the boat by applying all the knowledge that we have gained now. So we will make one hull from fully uncoated fibers and one hull from fully coated fibers. And what you see on the right side there is a mold that we have prepared made of wood, and we will use it to make a mold, the hull. So it's 1 meter length mold that we have prepared. So now I will move to the second topic that I am going to talk about, is about using those fibers for aerospace net zero applications. So we talk a lot about hydrogen, using hydrogen in airplanes. And the question that most organizations or companies in this area talk about is where to place the hydrogen tank. Should we place it in the middle, or should we place it in the wings? And this is actually a topic where many, many organizations and researchers are developing. But the question that we are actually investigating is from which material we should make this tank. So you can use steel, but steel is very heavy. So polymer composite could be a good candidate to make those tanks. And when you store hydrogen, so it has to be stored at liquid state. So when it's still in the liquid state, it's compressed, which means the pressure is very high, but also the temperature is very low. It's minus 252 degrees. So we need to prove that we can use composite to carry this temperature without breaking. So what I'm going to present is some investigations that we have done to make a tank from polymer composite materials. So composite or carbon fiber in that case is a very good candidate, but we have to prove that there is no leakage. Because if you have cracks in the composite, then you will have a leakage of the hydrogen. It means that there is a problem. So in this project, actually, there is a company in Sweden called Tickstream. They said, we will develop a material that can be used for this tank. And our task in this project was to prove that there is no cracks. So there will be no leakage if we store hydrogen. So just a short introduction to fibers and cracks, micro cracks, for you to understand this topic. So usually, the tank is made of layers. So we put layers, fibers, and matrix in different directions. And if you look with the microscope, this is what you will see. So you will see the fibers, which are in white in the lower picture, and you will see between the matrix. And usually, there is an interface between the fiber and the matrix, which is very important for our studies. So after loading this tank with hydrogen, so you apply a pressure and you apply a temperature, there is a risk that you see this type of microcracks. So it can be small microcracks between the fibers and the matrix. It can be what I call it matrix crack. It can be a crack between two layers, as you can see there. We call it delamination, or it can be fiber breaks. So in our studies, we try to investigate all these damages using this material and how it is. With that, actually, we applied a lot of mechanical testing, a lot of thermal tests as well. So this project was done in collaboration between our university, Tickstream, the company developing this material, carbon fiber, and RISE, which is a research institute in Sweden. So we did studies from specimen level, like coupon level working in the lab, to the tank at the end. So we made the tank, and the end caps, they were printed from titanium. So they were not made of composite. Only the pipe in the middle was made of carbon fiber. And we use a technique here, we call it filament winding. So we wind the fibers to be able to make the tank. So this is how we wind the fibers to be able to make samples to test in the lab. And this is how we wind the fibers to be able to make the tank at the end. And this method, they call it filament winding. So this was done actually along this project. And this is what we have done, filament winding. And what you see in the middle is a picture showing how the pipe it is made, and then we glued the end caps, which were printed from titanium. The picture on the bottom side in the middle is showing you how are the fibers if we look with the microscope to check how is the distribution of the fibers, how much fibers we have, and so on. And the picture which are in the right side is showing you how is the flat laminates are made and how they look with the microscope. So the pictures which are on the right side, this is something that we did in the lab to test the material, and the picture which is in the middle is the pipe itself. We made it as a demonstrator to test it. So this is some work we did in the lab, checking cracks at different loads. So we know what is the pressure that we want to apply, and we try to simulate that and apply similar load in the lab. We were checking some samples for small microcracks, but we have done also thermal fatigue or thermal shock. So as I said, we want to store hydrogen, and the temperature should be around minus 250 degrees. So we need to prove that this material can really stand at this temperature. So for that reason, we applied the thermal shock. So we put specimens in liquid nitrogen for a few seconds, which is at minus 196. And then after that, we took the specimens and we shocked them at plus 70 for 10 minutes. And we repeated this test 100 times. And this is really simulating the effect of filling in the tank with hydrogen, and then when the tank is empty, the temperature is increasing inside the material, and then you need to fill it again, and this is really showing or simulating like the number of cycles is how much you can fill in the tank every time. After that, actually, we did also some microscopic analysis, checking if we have any damage and if the material can work or not. And what we have seen, actually, we have seen only some cracks in some layers. So we have seen some cracks, but it was only in some layers, which means that the hydrogen actually will not be able to propagate from the inner part to the surface of the tank. So the hydrogen will be stored there, since the cracks that we have seen, it's only in few layers. So the hydrogen will not find the whole path to outside. So it will not be any leakage if we use this material. And this is the tank that we have made. So the pipe is made of composite. We have used actually titanium, as I said. But the wires or the steel bars that you have in the middle, actually those was just put for safety, because we tested this tank and we didn't want this titanium part to fly. That was a risk for us. So for that reason, we added these steel bars that you see in the middle, just for safety reason. And we have tested the tank. So we did this actually outside the lab, almost in the forest, in a very safe place. And we controlled the pressure. So here we applied liquid nitrogen, and we were measuring the pressure. And we succeeded actually to use this material for about 50% higher than the pressure that the company wanted. So with that, actually, we approved that this material can be used to make those tanks. And now this company, Techstream, actually is in contact with companies like Airbus, for example, who are interested to build this type of tanks for their airplanes. So with that, I would like to thank the organizer committee for inviting me to give this talk. Thanks a lot. It is a great opportunity for me to be here today. And finally, I would like to thank all of you for your attention. Thank you very much.
Thank you, Doctor, for the valuable presentation. شكرا جزيلا دكتور على المحاضرة القيمة. صاحب السمو السيد راعي المؤتمر، المكرمون وأصحاب السعادة، الحضور الكريم، نعلم يقينا أن النقاط التي وردت في المحاضرات السابقة قد أثارت كثيرا من الأسئلة. ولتعم الفائدة نتشرف بدعوة الفاضل الدكتور علي العلوي، رئيس فريق التربة والمياه الجوفية بشركة تنمية نفط عمان، للتكرم بإدارة الحلقة النقاشية. كما أدعو دكتور مارليز إيفرست، بروفيسور فيكتور جيكارا، دكتور محمد صاحبي الوكيل الصعود إلى المنصة للرد على الاستفسارات. Now it is the time for panel discussion, which will be moderated by Dr. Ali Al-Alawi, Head of Soil and Groundwater Team at Petroleum Development Oman. We would like to invite our esteemed plenary guests to take their seat on the stage. Thank you.
Okay, thank you very much. Thank you. First of all, do you hear me? I would like to thank the organizing. Thank you very much. I would like to thank the organizing committee for giving me this opportunity to share with you the importance of artificial intelligence and Internet of Things and how these technologies can support us to meet Oman the Vision 2040 in environment and sustainability. So, it is very important that is, with any advancing of economic, there is always a drawback of environment. We need to take care of it. And then new technology, AI and other can support us. So this discussion with the distinguished panelists, they already talk about it. But in this discussion, we emphasize mostly in how it's related to environment and sustainabilities. So I would like to introduce our panelists. So we already, we have you, maybe you can introduce yourself.
Thank you very much. Once again, my name is Victor Kara, and I'm a professor of supply chain and logistics management at University.
Good morning. I'm Dr. Marilise Everts. I'm a lecturer in advanced thermal engineering at the University College London.
My name is Mohammed Lukil. I am senior associate professor at Linköping University, and I work with material science and engineering.
Thank you very much. Thank you very much. So just for the time, so I'll go straight this question for all of you. How do you see the AI primary? Is it enabler to control the environment impact or challenges? Because we need to balance. I just want your opinion in this because there's a lot of debate in EA. Dr. Victor, can you start, please?
Thank you very much. It's a very good question. Whether AI is a positive enabler or a challenge for economic development, I suppose. And my strong belief is that AI is a tool, and as a tool, the results that we get from using a tool depends on how we use it.
Yes.
If we apply it positively and we think about how we apply it and we apply it with all the necessary resources around it, then it's going to be positive. If we apply it in a way that is not well resourced or not well planned for, then most likely we are going to get poor results or even negative implications. So I think AI is a very powerful tool. It's a very positive tool if we use it in a way that enables those positivities. And it could be dangerous if we don't use it properly.
Thank you, Doctor. Thank you, Prof.
Yeah, so I can definitely echo in terms of what you said, that it's a great tool. I tend to consider AI, it's a massive mind shift that we need to make. You gave the opportunity of the knitting machine. I usually use the example of a calculator. Just as we use a calculator to speed up our calculations and those kind of things, we can use AI to speed up our analysis, our research, and those kind of things. So in terms of research, it's a great opportunity. Yes, it does come with its challenges, but I tend to see the glass half full rather than half empty, and especially from a thermal perspective, it poses great challenges for us in terms of cooling these data centers and things, but who's not up for a challenge in research? So yeah, lots of thermal engineering research opportunities for us.
Okay, thank you. I think I share the same opinion with my colleagues, but I want maybe what I can add from my research areas. We use a lot of AI especially in like automating manufacturing, selecting the right material, being more cost effective, checking the quality of the product that we make. This is actually done by, or can be done by AI. But the point that I want to bring here is more about challenges, because AI is built on data sharing. And how we can share data on AI, because it's open actually, and it can be open to everyone. So I think intellectual properties are very important there, and especially if you work on topics like military topics, and then it can be very challenging how much data you can share and in which area of research you can really use AI. So.
Okay, thank you. Yes, I agree with you sharing, especially if you have sensitive data, ethics, you need to make sure that's not being hijacked by cybersecurity. You need to have a secured, because there's a lot of information. If you put it in normal terminal, it can be leaked to others. So I agree with you. It is very good tools. It can improve, especially environmentally, but also we need to take the concern when we design any system based in AI. So that's very important. Second question, this is directed to Ms. Mullins, Doctor. So from an engineering standpoint, how can artificial intelligence particularly contribute to improve the energy efficiency and reducing the emissions? So can this for you with those questions?
Yeah, so from a thermal perspective, in terms of improving efficiency of equipment and things, yes, we do need research for that. And using different research methods, complementary, creating hybrid approaches, is really a way to fast forward things. I'm an experimentalist by heart, but I do understand how much time very good experiments take, and then also the costs associated with it. And being able to incorporate AI in it, training models on very accurate data sets can enable us to really fast track research and technology, and be able to look into deeper things that we don't have to waste time in the lab doing experiments, extending the scope, pushing the boundaries, and really fast forward things for us. Yes, that requires suitable data center infrastructure, but again, it's a continuous development, and a chain is as strong as the weakest link. So we can't look at it in isolation. We really need to continuously look at the several interlinking factors and continuously develop them.
And this Dr. Mohammed, because you have a lot of research in the material. So this question also for you. Can you repeat this?
Yeah, actually, I mean, especially for materials and especially for manufacturing, we can use AI to save energy. So everything can be automated today by AI, so we can automate the manufacturing itself. We don't need really personnel to be, or technicians to be present, so they can control the quality using AI, they can control the whole process using AI, so they can save a lot of energy using that AI tool today.
Thank you, Dr. Ahmed. This question to Prof. Victor. So it's related question. What are the key economics and regulatory challenges from regulatory challenges that may hinder the adoption of AI-driven sustainability solution, especially in developing country economics and resources-dependent countries? So how that can be impacted by economical, by regulatory requirement, and so on.
Thank you. That's a very big question. So I'll take a supply chain perspective to this, and basically reflecting on the economy much more widely. I think effective regulation of the development and the deployment of AI is essential. And the question at the end of the day is how comprehensive is the regulatory infrastructure. over the past 3 years, I've had the opportunity to peruse through Oman Vision 2040. And I find it very comprehensive. It touches from the people aspect to the business aspect to the environmental aspects. And I think with those kinds of regulatory infrastructures, with those kinds of national AI strategies, governments are in a position to better manage the deployment of that technology, and also taking more control over the development of the technology of AI. So one thing I see in the Oman 2040 vision is the commitment to resourcing the talent, for example, not just the technology, but the talent. So development of the talent, so the young people well-trained and well-equipped to not just use the technology, but also develop the technology. And I think that's very important, because what it means is that you're not only continuously relying on others to supply the technology and then you become net users, but you're part of the development of that technology and therefore ensuring the future economic prosperity of the economy. I hope I've answered the question.
Let's go, sir. So regarding, what did you think which priorities area that? Sorry, for Dr. Maris. So which is priority you think Oman need to implement, use AI to achieve environmental sustainable based in 2040? So which things that it will support, which part of EA that can be support to implement, to achieve the goals of our 2040 vision?
Again, speaking from a thermal perspective, there's a lot happening behind the scenes in terms of AI. We tend to think of it as a black box. We just want to use it, but in order to make this black box happen, there's a lot of things necessary that has a significant environmental impact from a materials perspective, but then also in terms of a cooling perspective. At the moment, data center and AI infrastructure consumes massive amounts of water in terms of cooling requirements. It is a huge energy consumption, and all of that really boosts global emissions. So to really get to net zero and to contribute to a more sustainable future, a lot of our thermal engineering research at the moment is going into different cooling fluids, dielectric fluids replacing the water usage, but many of these are also unfortunately PFAS based, so that's again an environmental issue. So nowadays we're really pushing, and I'm collaborating with industry to see how we can make our data center cooling infrastructure more PFAS free in terms to boost the sustainability, and being able to make them more efficient also brings down the energy costs and then automatically reduce the carbon emissions.
Okay. Thank you. Dr. Mohammed, do you want to add something related to which priorities should taken to enhance environmental improvement related to the EA?
I share the same opinion with her. And what I can add actually that, based on your vision 2040, we can really use AI today for renewable energy, but also hydrogen. This is also a topic where AI can be used a lot, and it will be more and more developed in the future, and I think this is a great tool to be used in the future to achieve, or at least support to achieve your visions, in my opinion.
So one question, I will answer it because it's related to oil and gas. So the mission, how how can artificial intelligence support transmission towards sustainable practice in oil and gas. Of course, there is many opportunity in oil and gas to use AA. First, we're starting from exploration to use very database using AI, and then during the drilling, and also maintaining supervising the emission from our facilities that can be implemented, carbon emission, carbon captures, and controlling, because you can have different technology based in AIA that we utilize. In addition to that, also we as oil company have a lot of water. Also, they can monitor the water networking. If you have also many pipelines, you can use maintenance, predictive maintenance, use IA, and also you can detecting leak and spills using the IA. There are a lot of opportunity, and we are in video. We're already starting some of these projects, which is in line with this is our emission as Oman strategy to enhance implementation of AI. So this is in oil and gas. Just to conclude, because I've been asked not to take more than 20 minutes, so I'll go to the last questions. So I need from each of you, what is your key point to let me track this. This is a question what I've been received, so let me to be in line with these questions. So what the point that you think that is a key message you want to give it to people in Oman, governments who controlling the environment and sustainability, like Environment Authority and others? What's the key advice you want to give them in order to meet our goals in 2040 in environment, reducing emission, and reducing the impact of environment with our enhancing economic and industry increasing? So we need to take something. So what is, start from you, Dr. Victor?
Thank you. The key message, I started by saying that I find Oman Vision 2040 quite comprehensive, which is a very good thing. Some of the research that we've been doing recently on the regulatory infrastructures for AI shows that not many countries have actually come to that level of thinking forward about these things. The message that I would like to give, and again, coming from the perspective of a sociologist interested in supply chains and technology, is that at the end of the day, whatever strategy and policies we are thinking about, we have to bear in mind three points. One is that a country is the people. The second point is that the people are the workers that drive the economy and use these tools that we are talking about. The third point is that these people are also the buyers of the products that we develop. So when we are talking about enhancement of technologies and enhancing economic productivity, people have to be at the center of it. So we equip the people to be able to use these technologies. We equip the workers to be able to effectively work within environments that are safe. But at the end of the day, we also have to think about how, to what extent these people can afford to buy the product that we are developing in order to drive the economy forward. That would be my message. I think put people in the center of these advancements and innovation, and I think we can go wrong with that.
Thank you. Same questions for you.
Yeah, and I'm in full agreement. AI is a tool, it's not a replacement. We need to keep in mind the people, especially from an academic point of view, focusing on the students. Our students are our future. We need to train them to use AI wisely, to use it to take their ideas, their skills further. I see a great risk in not managing this correctly, and then instead of developing these engineering mindsets, they turn off their engineering mind and they just completely rely on AI. So for me, yes, we need to use it wisely, use it as a tool, not as a replacement, and also make sure that the students understand that AI comes at a cost, and so developing their skills to use it, but then simultaneously develop the AI infrastructure so that it has a lower effect on our environment.
Thank you very much. Dr. Mohammed.
Yeah, thank you. Actually, I find the vision very, very interesting, and I think this event today will play a part, or a big part in this vision, because in my opinion, to succeed that vision, you need a lot of stakeholders or players, and one of them are researchers and universities. So my message is to like support researchers, because they will play a big role to achieve this vision. So supporting them by like research project on those topics to fulfill the vision, try to coordinate projects, but also collaborate with others, not only be like working separately, but collaborate with others and be open with international universities and other universities to make this vision successful. And in my opinion, the vision is really great, because, I mean, this is what we talk about today. So, and I think this event actually will play a big role to achieve this vision, in my opinion.
Thank you. I have just one question. Since all of you from academia, I want to understand, because also we have our EJAD terminal, which link industrials and academia. From your experience, how this relation between academia and industrial to get these projects, R&D project in different. So I don't know, because we have already a system in Oman, but we want to learn from from the different countries. If you can just to help the people, we have from people from industrial, we have people from academia. For you, pictures.
Thank you once again. The collaboration between industry and academia is essential. Because from our universities, the different stakeholders, but primarily the government, spends a lot of money to resource and equip universities. And whereas industry might have their internal research capabilities, or they might have private firms that do research, I think within universities we have much bigger resources, much bigger knowledge base, and much bigger, actually much cheaper. Because working with universities is definitely much cheaper than working with KPMG. I have nothing against KPMG, but at the end of the day, we as public universities, or even private universities, we have a responsibility to do the work that we do without having to make a profit out of it, because we are being resourced by the university, by the government. So I think for private sector representatives in the audience, forging closer collaborative relationships and partnerships with universities and researchers like ourselves is probably the best way to go.
Thank you. Thank you, Prof. Yeah.
Yeah, I definitely agree.
I want your experience, your country experience. It's better to be linked to what's practical.
Yeah, so in terms of industry and academic collaboration, that's absolutely essential. From the UK perspective, we put a really high emphasis on industry-academia relationship. At UCL, we even have knowledge transfer programs, which is basically a program or a research project that's initiated by industry. So they have a problem, and instead of them wasting their resources on the research part, they partner with us at UCL to conduct the research. And it's absolutely mutually beneficial, because the company gets the abundant expertise from a research perspective. However, we get that industry-driven ideas, approaches, problems. It creates a sense of, it creates value for us because we then generate research with impact, and it changes the world for the students and the researchers that's involved in these projects, because for them it's no longer a textbook or an academic exercise. They're very motivated because then they see what they do, how that fits into society, and then the benefits of it on the economy.
Yeah, thank you. I think, this question is very relevant, and the relationship between industry and academia in Sweden is very strong, both in teaching and research. So, for example, in teaching, at least in each course, you have a guest speaker from the industry coming and giving a lecture. So it has to be something linked to the real application from the industry, and students really enjoy that. So they enjoy a person coming from the company and telling them about what they do and how they will use the knowledge that they will gain during this course in a real application. That actually attracts students. And also, there is another thing that we do a lot in Sweden is what we call it a study visit. So in each course, we plan a day where we take students to visit a company and see what they do in real life. So how the engineers work there, and they understand how is the life in the company and how they will use the outcomes from the course at the real company. This is when we come to teaching. When we come to research, our research projects, usually they are applied. So there is a question that comes from the company saying, we have this problem and we want you to solve that problem. So then we apply for funding to solve that problems, and usually the funding that we get from the government, the Swedish government, is only 50% of the total funding. The rest 50% come from the industry. So it's a close collaboration between the industry and the government. So all the research that I do is really applied, and you saw today, so marine application, aerospace, so all of them, they are linked to questions, real questions and real problems that come from the industry. So the relationship between industry and academia is very strong, and this is really good for students and also for us as a researcher to enjoy the work. As a researcher, you need to know that there is a problem and you are solving that problem.
Okay, thank you, Doctor. I would like to thank our distinguished panelists for this discussion, ending our discussion today, and I would like also to thank the organizing committee to give me this opportunity to moderate this panel discussion. Thank you very much. Thank you.
حضورنا الكريم، ختاما يسرنا دعوة صاحب السمو السيد فهر بن فاتك بن فهر آل سعيد الموقر راعي المؤتمر، وسعادة الدكتور سعيد بن حمد الربيعي رئيس جامعة التقنية والعلوم التطبيقية، بمعية المكرمة الدكتورة حنيفة بنت أحمد القاسمية مساعدة رئيس الجامعة بفرع صحار، للصعود على المنصة لتكريم المتحدثين الرئيسيين وكذلك الرعاة الماليين للمؤتمر. الدكتورة مارليز إيفرتس. البروفيسور فيكتور جيكارا. البروفيسور محمد صاحبي الوكيل. الدكتور علي العلوي. ممثل الشركة العمانية لدرفلة الألمنيوم أوراق. ممثل شركة دليل للنفط. ممثل الشركة العمانية القابضة لخدمات البيئة بيئة. والآن يتفضل سعادة الدكتور سعيد بن حمد الربيعي رئيس جامعة التقنية والعلوم التطبيقية لتقديم هدية تذكارية لراعي المؤتمر. ختاماً نتوجه بجزيل الشكر إلى صاحب السمو السيد فهر بن فاتك بن فهر آل سعيد الموقر راعي المؤتمر، وإلى ضيوفنا الكرام على تشريفهم لنا بحضور حفل افتتاح المؤتمر الدولي الثالث للعلوم والهندسة البيئية والتنمية المستدامة. وندعو صاحب السمو السيد راعي المؤتمر وسعادة الدكتور رئيس جامعة التقنية والعلوم التطبيقية بمعية المكرمة الدكتورة مساعدة الرئيس بفرع الجامعة بصحار لافتتاح معرض الملصقات العلمية. ونلتمس من بقية الحضور البقاء في مقاعدهم لحين خروج صاحب السمو والسيد راعي الحفل. نشكركم جميعاً وندعوكم لزيارة معرض الملصقات العلمية بعد قليل، ثم تناول وجبة الغداء بعد انعقاد الجلسات المتزامنة وفقاً لجدول الجلسات، والذي يمكنكم الاطلاع عليه عبر الرابط الظاهر في الشاشة. شكراً لكم جميعاً، والسلام عليكم ورحمة الله وبركاته.
الفضول والأسئلة. تيار متدفق بلا توقف يجسده العقل البشري. في لحظة أدركنا عمن نكون. نحن طاقات مشتعلة تعتنق البحث والاستكشاف. هنا نبدأ فصلاً جديداً من الإمكانات، نتعلم وننمو معاً. هنا جامعة التقنية والعلوم التطبيقية. مؤسسة تتيح لمنتسبيها الوحدة والتمكين والتطور واستدامة التعليم بطرق عصرية ومسارات واعدة. لتبحر بخيالك وترتقي لمراحل متقدمة في العلم والعمل. في أرجاء عمان تتوزع فروع جامعة التقنية والعلوم التطبيقية تماشياً مع رؤية عمان 2040 لتلبي احتياجات سوق العمل بتنوع برامجها وتخصصاتها المطروحة. عصر جديد يملك من التقنيات والمعلومات حلولاً لا تحصى، بدأ فيه أولئك الشغوفون باكتشاف معالمه وخباياه. وبين اليوم والأمس نكتشف تفاصيلاً دقيقة وعناصر تمكننا من عيش حياة صحية بشكل أفضل، نكتسبها بالبحث والتجربة. ولنملأ الفراغ لا بد لنا من هندسة تملي وجه الحقيقة. هنا نتعلم ما الذي يحرك العالم وينهض به في وجه الحضارة. أشكالنا تعبر عن حماسنا. هنا نكتسب تشكيل التعبير الثقافي من تراث وهوية المجتمع. الصناعات الإبداعية بتخصصاتها المميزة وسيلة تترجم وترفع من أصواتنا في كل الأنحاء. نواصل مضينا للأمام نحو تيار لا بد له من توجيه يبقيه في الصدارة ويفتح له من الفرص الكثير. كل جيل يتبعه جيل آخر، هرم يتصاعد رتمه لوجه السماء لنخرج جيلاً برؤية أعمق وأسمى. إن تخطيط المستقبل هو الحل. منذ البدايات فإن جامعة التقنية والعلوم التطبيقية تعمل على بناء جسور التعاون الأكاديمي والعلمي المشترك على المستوى الدولي، فالحوار المشترك نقلة نحو المستقبل. نحن هنا كلنا متساوون، نملك كل تلك الأسئلة والفضول لنعبر عمن نكون. جامعة التقنية والعلوم التطبيقية